Welcome back. So hopefully throughout this investigation, you noticed two things. The first one is that in similar polygons, the measurement of corresponding angles are congruent. Take these as an example. So here I'm telling you that these two triangles are similar. So when you have similar triangles, we know that the measurement of corresponding angles need to be congruent. Corresponding is just a very fancy way of saying that they're in the same position. So for example, 85 degrees, angle ABC is in the same position as angle XYZ. So then those two angles are congruent. So here the same thing, 50, 50, 45, 45. And if we want to write it out, we can do that as well. Here I have written down the angles for this green triangle. So angle ABC is 85 degrees, A, B, and C. ACB is 50 degrees. And then BAC, that one is 45 degrees. For this yellow triangle, the similar one, we're going to have to mimic the order of the letters. So here, notice that I started at A and then went to B and then ended at C. So I'm going to mimic this pattern. So I'm going to start at X, go to Y, and then end at Z. So I have angle XYZ. And that's what we mean by corresponding. Angle ABC corresponds to angle XYZ. Since they're similar, they both have to equal 85. The same thing is done for the rest of the angles. Here, we want to avoid confusion and remain with consistency. So although we can rewrite angle YXZ as ZXY, we are not going to do that because again, we already established that this green triangle is BAC. So for, again, consistency, the yellow one has to mimic that pattern. So this one can only be named as YXC. So that's incredibly important, or else you're going to start confusing a lot of things. Now the second thing you should have noticed was that corresponding angles are congruent. And I apologize, I made a typo. It should really say corresponding sides are proportional. That's the second thing you should have noticed. So for example, I'm going to give these two triangles some lengths. So let's assume that AB has a length of 15, BC has a length of 6, AC has a length of 12, and then here we have 5, 2, and 4. So again, these triangles are similar, which means that the corresponding sides need to be proportional. So what exactly does that mean? Well, let's go ahead and do it. I'm going to show it to you. Let's begin by grabbing a couple of corresponding lengths. Here, AB corresponds to XY. So I'm going to get AB and divide it by XY. Again, AB corresponds to XY. AB has a length of 15, XY has a length of 5. And if we reduce this, we see that we get 3. So we're done with this part right here. So let's grab another pair of corresponding sides. This time I'm going to grab AC and XZ. So AC corresponds to XZ. So let's get AC, divide that by XZ. AC has a length of 12 and XZ has a length of 4. So 12 divided by 4, we get 3. Now, because these two triangles are similar, because I explicitly told you, the last pair of corresponding sides need to equal 3. And let's just verify that. So the last pair of corresponding sides are BC and YZ. So let's get BC divided by YZ. And we're going to get 6 over 2, and like expected, we're getting 3. Now, when you're doing these problems, if your corresponding sides are not proportional, then you can claim that you do not have similar polygons. Likewise here, if your corresponding angles are not congruent or they're not the same, you do not have similar polygons. And that's going to be what we're going to be doing for the rest of this assignment. So let's begin by going over some examples, beginning with this one. Example 1. Are the following polygons similar? If so, what is the scale factor? Present your claim, show your evidence, and explain your reasoning. So I'm going to demo how I want you to attack these problems. So here we have to make a claim. And the claim is either going to be yes, the polygons are similar, or no, the polygons are not similar. Then for the evidence, that's basically going to be our work, and then we're going to have to explain our work. That's going to be the reasoning aspect of this problem. Before we make a claim, let's actually just play with this problem and see what we get. If we want to determine if these two polygons are similar, then we have to do both of these tests. The first one, we got to make sure that the corresponding angles are congruent. If we succeed, then that's going to lead us to testing out the corresponding sides, making sure they're proportional. If we're able to detect that two corresponding angles are not the same, then we don't have to bother with doing this second part. We're going to be able to immediately conclude that the polygons are not similar. So let's begin again by doing this first part, making sure that corresponding angles are congruent. Now, since these problems, I'm aware that they can be a bit lengthy, I'm going to let you do a shortcut with the angles. So here, for example, we're going to have angle A. So angle A corresponds to angle X. Right? These have the same position. So angle A corresponds to angle X, angle B corresponds to angle Y, and angle C corresponds to angle Z. Now we have to make sure that the corresponding angles are indeed the same. In geometry, we say objects that are the same are congruent. So angle A is congruent to angle X. The measurement of angle A would be equal to the measurement of angle X. So we got this under our belt, so let's try the other two angles and see if they're also congruent. So now we have to check angle B and angle Y. Those are also corresponding, and let's see if they are congruent. So for angle B, I have 2 tick marks, and for angle Y, I also have 2 tick marks. So here we are gonna say yes, they are congruent. So we have to check the last one. If the last pair of corresponding angles are congruent, then we can establish that the first part is good, and then we would have to move on to the second part. If, however, the corresponding angles are not congruent, then we can immediately claim that they are not similar. So let's go ahead and test the last set, and that's angle C and angle Z. And here angle Z has 3 tick marks, angle C has 3 tick marks, so yes, these are also congruent. So perfect. Nice. Since corresponding angles are congruent, let me actually write that down. Now we're gonna have to do the second part. We gotta see if corresponding sides are proportional. So let's begin with BA and YX. Here we see that BA corresponds to YX, so I'm gonna create a ratio here. BA has length of 10 and YX has a length of 5. So 10 over 5, that's the same thing as 2. Let's test out the other pair of corresponding sides. Now I'm going to get length AC, and AC corresponds to XZ. So I have AC, and I'm going to divide it by XZ. And we see that AC has a length of 12, and XZ has a length of 6. 12 over 6 is 2, so far we're looking pretty good. We got to test the last part here. Now we have BC, and that corresponds to YZ. So I'm going to get BC and divide that by YZ. And BC is 14, while YZ is 7. And 14 over 7 is 2. So we take a look at all of these sides, because that's all of them. And we see that, yes, we're getting 2, 2, 2. and so all of the corresponding sides are proportional. And if your corresponding sides are proportional, this value right here, that's called your scaling factor. So here the scaling factor will be 2. Alright, so now we're going to do this part here. We're going to answer this question using claim, evidence, and reasoning. So we're going to present our claim. So since we already solved the problem and we figured out that corresponding sides are proportional and corresponding angles are congruent, that tells us that we have similar polygons. So our claim is going to be the polygons are similar. Our evidence is this part right here, and then we're going to explain our reasoning. So let me map it out on a separate sheet. And here is a complete answer to the problem we just did. So our claim is that the polygons are similar. The evidence would be all of the work that we did, checking if the corresponding angles were congruent, as well as checking that all corresponding sides were proportional. Finally, the reasoning explains your evidence and solidifies your claim. So here we're going to write all corresponding angles are congruent and all corresponding lengths are proportional, having a scale factor of 2. For this example, it was 2. Therefore, the polygons are similar. And there you have it. Alright, let's check out one more example. So example 2. Are the following polygons similar? If so, what is the scale factor? Present your claim, show your evidence, and explain your reasoning. Going back for the definition of similarity, we have to first check if the corresponding angles are congruent. And if we succeed, then we begin to check the sides. So let's see what happens here. So we gotta check for the angles. And here, every time you see this little square tick mark, that's telling the reader that we have a 90-degree angle. So that's 90 degrees, this is 90 degrees, the same here, and the same here. And we see that this square is rotated, so let's make sure that it's in the same position as this big one right here. If we want to get corresponding sides, the first thing we have to make sure is that both shapes are facing in the same direction, same position. So now that I've done that, let's start getting corresponding sides. So here we see that angle K corresponds to angle N. Now we have to verify if they're congruent or if they're not congruent. So here I'm getting 90 degrees and here I'm getting 88 degrees. So immediately we see that these are not congruent. And here we were able to spot early on that these two shapes have no hope of being similar. So in our previous example, here we could claim that they were similar, but here we can't do that. And let me give you an outline on how to write this solution for whenever you get to polygons that are not similar. And here we have a complete answer. So here, this time we're going to claim that polygons are not similar. Our evidence was that angle K is not congruent to angle N. And the reasoning, corresponding angles are not congruent. Therefore, I can conclude that the polygons are not similar. And we are done. So go ahead, try the problems that follow, and I will see you on the next lesson.